JC, what's up? Coach Johnson here with Precal 12, 5.1 to 5.4 review. Hope you're having a great night tonight as we get going on the studying here. I told you it'd be maybe a little bit lengthier of a podcast. Feel free to text me at any time. Or if you go on the Remind 101, that will work too. I get both of those, so either way is fine by me. Again, any questions up there? If you have questions off of maybe of a quiz or homework, feel free to text me at that too. What we're going to do is I'm going to start with one that Taylor had in class that I didn't get to in class. So I want to do that one in order to follow through with that, and we'll go from there. All right, what to do? Let's get this party started. Very good. Okay, so first thing we have, number one, is we have a sine of pi over 2 minus x. Now, one thing to remember is that anytime I have this is called a cofunction identity. We know that in this instance that we have this would be equal to cosine of x. So since we know that that's equal to cosine x, that helps me out a lot because it allows me to see that, okay, cosine of x will be the same value as sine of pi over 2 minus x. So this would be negative 7 over 25. So I'm going to write that in. I'm going to write negative 7 over 25. And that's going to end up being what cosine of x is there. Now, since cosine of x is that specific value, I'm then going to go over to the second part, which says that cotangent of x is equal to, and it says it's equal to negative 7 over 24. Okay? All right, so one thing to remember is that the cotangent here, sorry about that, let me backtrack. The cotangent of this is, there we go. It's equal to cosine over sine. So we'll plug in what we know and we'll leave what we don't know. So like for instance, cotangent's negative 7 over 24. Okay, so we've got that there. And is equal to the cosine, which is negative 7 over 5. Let's get that there. And this is all over the value of x. Now, one thing we can do is you remember, and you kind of see it here, that when I figure this out, or when I simplify, I'm going to multiply this by x over on both sides, and then I'm going to divide by negative 7 over 24. So really, I'm multiplying by the reciprocal of this once I divide to either side. So what I've got is x is equal to negative 7 over 25. And remember, this we're going to divide on this side, so divided by negative 7 over 24. But if I were to flip this to the top, right, do the flip-de-flip, right? It's a good mathematic term right there. We're going to multiply by its reciprocal, 24 over negative 7. So 7s are going to cancel, leaving me with 24 over 25. And that would be my answer. You might say, well, how did you get a positive? Remember, both are negative, right? So that's how I got to my sine value right there. Now, remember how to find cotangent, cosecant, and secant. I can just simply flip and find the reciprocals of those three to find that answer that's there. Okay. So hopefully that makes sense for those. So like secant would be negative 25 over 7. Cosecant, where's the sine? Cosecant would be 25 over 24. And tangent, reciprocal of cotangent, which is negative 24 over 7. Remember, with the reciprocal, you keep the sign, but however, you do change, you flip it from what was top and bottom. We flip-flop those, okay? Awesome. I did see a question also come through here. I'm going to kind of pull that up. Feel free to, again, text me or do what you do there. Get me on that. Hit me up there, and we'll go forward. Let's see. Where's that? Remind 101. Let me see. Looking here. Oh, there you are. Okay. Yeah, I see some questions that are popping up here, so we'll hit on those. Perfect. Let's do one of the identity problems. Just got a shout out there. Let's do one of the identity problems. Let's do on the back side. Oh, yeah, let's do that one. Let's do number 6 real quick. 6 is a good one. There's other ones there, but I think 6 would be a good one on that. Okay, so we're going to do secant squared. We have tangent squared plus secant squared of x, and that equals secant to the 4th. Now, one thing to remember on these is we want to pick the toughest side first. We know on this one, the left side would probably be the toughest. Now, one thing you can do is you can convert this to sine and cosine, and you'll get the same answer. However, what I like to do in this situation is I'd like to look to see, is there anything I can factor out? That's something to another strategy. Remember on the test, the big thing to remember is that in either situation, you can just try something, and that will give you credit as long as it makes sense and follows the mathematical pattern and goes from there. So what can I do to take, what can I take on the left side? I can take secant squared x on the left side, right? Now, once I take that out, I'm left with tangent squared of x plus 1, right? It should be plus 1. And that equals what's on the right side. So once I look at this, I can then think, okay, I see tangent squared plus 1. I know that may be an identity that's there. And as I look at that, I think online, I look at my formula sheet, and I know that is going to be secant squared of x is my, in my formula sheet, that's what I would get here. So I have secant squared x times secant squared x, which would be secant to the 4th x. And again, I look right there, I see, oh, that's matched up. Boom, got matched up on that right side, and we are done. All right, so that's one right there. Let's take a look at another one that we kind of got a couple identities in there. I know I looked at number 7 there. Look at 5. 5's pretty easy because remember sine squared of pi over 2 minus x is cosine. And since it's squared, it will be cosine squared, and sine squared plus cosine squared is 1. That's a pretty easy one there. Number 7 was a tough one just because I know that we were doing it in class. One of the things we said in class is we converted the left side to sine and cosine. So we have 1 over sine, right? Plus 1 over cosine. And then on the bottom side, we have just sine plus cosine. One thing that was a little bit of a problem here was when we were trying to solve for this one, we noticed that this was missing a cosine. So if we put one here, we got to put one on the top as well. This one was missing a sine, so in class today, in one of the classes, I put a sine on the top there as well on that side. So on the top one, I have cosine plus sine all over cosine sine. And this is all over 1 over sine plus cosine. Okay? Now, once I do this, I'm going to flip this to the top. And when I flip it to the top, I'm going to multiply it by 1 over, my fault. It shouldn't be 1 over this. I'm sorry. I'm flipping it, which turns it into 1 over sine plus cosine. Now, cosine plus sine and sine plus cosine are the same thing. That's an important thing to remember because that basically will allow us to cancel both of these out, leaving me with 1 over cosine sine. Okay? Now, I know what you're thinking, Coach, that's not the right side. In fact, that's not correct. The right side is cotangent plus tangent, and you'd be right. You'd be absolutely right. One thing you can do is then kind of maybe split it up. If I have room on the right, I would, but I would just put it down here. Let's change that other side, cotangent plus tangent, in terms of the same thing. So we're going to just do the same thing. So we're going to convert cotangent to cosine over sine. And it's going to be plus sine over cosine, okay, because that's tangent, right? And so what's happening is this is missing a cosine here. So if I put a cosine here, I multiply the top by cosine to get cosine squared. And this is missing a sine, so I'm going to put one here, which makes the top squared. So then I've got cosine squared plus sine squared all over sine cosine. Well, as you could see, you could probably see the writing on the wall here that the top side is an identity, which is 1, which would be 1 over sine cosine. And that will help us basically we match up our answers from one to the other there. So hopefully that was helpful for you. That was a tougher one that you may have to use some different steps in order to solve on that. Another one, number 4, you may want to factor that left side. That number 4, you factor it to cosecant squared plus cotangent squared times cosecant squared. One's plus, one's minus, so whatever one I didn't say, I apologize. Factor that out and then try to use an identity off that going forward, okay? All right, let's see how many people are on. I just want to make sure, see what we've got. I know we've got quite a few viewers here, so feel free, if you got a question out there on one specifically, feel free to ask that question, and we'll go through that together on that one. I'm guessing number 2 is pretty easy. I'm trying to think of another one that. Oh yeah. This one, the one I'm about ready to give you is trying to see if it was on the makeup quiz. I don't think it was. This one is one that will be on the test too. It's one where I say, what's 1 over 1 plus sine, right? And I say, get it out of fractional form. A lot of people had problems on this on the quiz because a lot of people just forgot, oh, how do I simplify that? How do I get it out of fractional form? And one thing to remember is a lot of times this is going to be multiplied by my conjugate. So what I'm going to do is I'm going to multiply by 1 minus sine here. And when I do, I get the top as 1 minus sine. And on the bottom, 1 minus sine times 1 plus sine would be 1 minus 2 sine, or I'm sorry, minus sine. Then we have a plus sign, that's better, and minus sine squared. You might say, why'd you do that, coach? Because one thing to remember is I do distribute, but when one's a plus and one's a minus, the middle ultimately falters, kind of changes a little bit. So this bottom part should be 1 minus sine squared, okay? Now, one thing to remember is that anytime I have a sine squared, cosine squared, something squared, I just look and see, is that an identity? And I know that that identity is, that it actually is an identity. That's actually equal to cosine squared theta. So how can I change cosine squared to where I put it towards the top? So I've got this up top because I'm trying to get out of fractional form. If cosine squared's on the bottom, if I bring it to the top, that's going to end up changing it to secant squared of theta, right? And then that's multiplied by 1 minus sine, okay? And so that would be it. That's out of fractional form, whatever you need to do to get out of fractional form. Now, you could distribute secant and go from there, but that's not necessary. You could just leave it as is, especially if it says get out of fractional form, and that's all that it put there, okay? Sure. I'm trying to see if there's any other ones that, all right. Perfect. All right. Awesome. Okay, so we've got all of that there. Is there anything else? Any other questions out there? So we got that one. Looking and seeing. I know we did some today. As you start getting questions, as questions continue to roll in, let's do number 9. I'm just trying to do a plethora of different questions you'll have. This may not be as long, maybe not today. I'll keep going as long as I need to on that. Really will. I'm here for you. All right. Okay, so left side. Let's look at the left side here. One thing we remember, just like we did earlier, cosecant squared minus 1. Is there an identity that gets me, simplifies as cosecant squared minus 1? One thing we can remember is, if I think I remember right, that I think this identity would be cotangent squared, wouldn't it? When I change it up and all that, I think it's cotangent squared plus 1, and I subtract 1 to get cotangent squared in for this. So one thing to remember is that when I set this equal, I should have cosecant squared over cotangent squared. So now what I'm going to do is I'm going to convert all of this into terms of sine and cosine. So cosecant squared is 1 over sine squared. I'm going to put that down. And cotangent squared is cosine squared over sine squared. So I'm going to flippy. Okay, flip this to the top. Good. And once I get to that point, what happens is the sine squareds cancel, leaving me, and this should be squared here, 1 over cosine squared, which is equal to secant squared of theta or x or whatever we're working with there, which is the same thing on that side. Now, one thing to remember too, to just make sure that you understand, make sure I follow like the logical pattern going down. One thing is like sometimes I saw them and I was headache trying to grade, like the work was all over, and I'm fine with that. Just make sure that when you do it, you just kind of flow it down. It can have a lot of work on it. Just make sure it flows down appropriately on that. Okay. Awesome. Sweet. Trying to see. One thing too, like number 10 is a good one. It's a good one. It's a real good one. It says sine of negative x right there is equal to negative 5/7. So one thing to remember is that sine of negative x, this is just formula stuff, is equal to negative sine x. So what does that mean? That means if sine of x is, or I'm sorry, negative sine of negative 7 or negative x is negative 5/7. What I could do is I could plug this in here, but if I want to try to get positive, I'm gonna have to change the sign. So really 5/7 is sine of x. Okay. So one thing to remember here, I'm gonna go right there. We go. Again, if you have questions, keep them coming. But one thing we can do now is because 5/7 is sine, I can then know that cotangent of x is equal to 2 root 6 over 5. Okay, so now I can go cotangent is equal to cosine over sine, just like that. And just like I did before, I'm coming over and I say, okay, cosine, I don't know what that is, so I'm going to make that x. Sine I do, sine is 5/7. Whereas cotangent is 2 root 6 over 5. So what I'm going to do is multiply by 5/7 on both sides. So I get 5 over 7 multiplied by 2 root 6 over 5. Fives are gone like a freight train, gone like yesterday. Gone like a soldier in the Civil War, bang, bang. To get 2 square root of 6 all over 7. And that's cosine of x. But it didn't ask for cosine x. It said, what is cosine of negative x? Well, we know that the formula is equal to cosine of x, right? Actually, cosine of negative x and cosine of x are the same. Therefore, 2 root 6 over 7, since that's cosine of x, I plug it in. So they're actually one and the same, so we'll leave it as is. Okay. All right, while I wait for some extra questions here, I'm going to go get a quick drink of water. My voice is kind of parched there. Try this one. I want to go the first page. We kind of hit on pretty hard there. You can look at other ones if need be. Let's do number 20. Let's do number 20. So I'm going to come straight back. Make sure you get number 20. I'll be right there. Get some water. My voice is gone. All right. Awesome, awesome. Okay, let's see here. Okay, let's take a look at some more here. And as we keep going, feel free to keep texting away. Number 20, we've got sine. of 5 pi over 12. It should be 5 pi, I apologize. Okay, so one thing we want to know is that, or one thing we want to utilize is anytime I give you something where it's just 1 radian and we're trying to expand this out using sum and difference, let's convert this to degrees. And one way we can do that is taking 5 pi over 12 and multiplying by 180 over pi. So once we do that, we know that the pi's will cancel. We know 12, we can do this on our calculator. 12 goes into 180 15 times, and 15 times 5 gets me, you are right, 75. Nicely done. Okay, so what do I do now? In your house right now, I want you to yell out loud as you can. What would I do now? What 2 angles on the unit circle add or subtract to equal 75? Right now, you're not too cool. Very good. I hear a lot of you out there. Nicely done. So this is going to be not 35. I'm sorry. Mixed them up. 45 plus 30. Okay, so we're going to add those 2 together. And remember, those 2 angles add up to be equal to 75. So now we've got sine of A. Remember, A is 45 degrees. So sine of A, cosine of B, just 30. And then it's plus cosine of A, cosine of 45. Sine of 30. Okay. You might say, Coach, how did I get that formula? Remember that the formula of A plus B, that value of sine of A plus B is on your calculator, that you're just literally plugging in and chugging, plugging in, going from there. Okay. So then we just simplify. So like sine of 45 degrees, we know is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. And sine of 30 would be 1/2. So now it becomes pretty simple because now I just distribute to get square root of 6 over 4 for this first one. And then the second one would be square root of 2 over 4. Okay. Now, when I simplify and add, I get square root of 6 plus square root of 2 all over 4. And we'll leave that as is. Remember, square root of 6 plus square root of 2, I cannot add because they're not the same square root. Can't add those together. So we'll leave that as is, and we're G to G. Good to go there. Awesome. Let's look at number 15. And I'm just doing random ones. So if you, again, you have a question on one, please let me know. I'm going to log in, make sure that we don't have one there. Let's see. Perfect. Okay. Let's do this one. Let's go to 4 cosine squared. Awesome. Okay, so we want to get x by itself because that's really what we're trying to do is isolate x. So we're going to add 3 to both sides. Remember that with this one, this is not a an interval one, so we've got to add 2 pi in. So just kind of keep that in the back of your mind there, because eventually we'll add 2 pi into our answers because it's not from 0 to 2 pi as 11 and 12 are in that case. So we're going to add 3 here, and then we'll divide by 4. So we should get cosine squared of x equals 3 over 4. Okay. Now in this situation, we're going to square root both sides, to where then cosine of x is equal to the square root of 3 all over, we know the square root of 4 would be 2. So, and remember, it's plus or minus 2 because we know that anytime we square root a squared, we'll leave it as plus minus. So my question is where is cosine square root of 3 over 2? So I know that there's going to be 2 places there, right? Well, really 4 places, 2 that are positive and 2 that are negative. And I know that square root of 3 over 2 would be anywhere where it's like over 6. So we'd say pi over 6, 5 pi over 6. It would be 7 pi over 6. Good. And last but not least, we have 11 pi over 6. And then at the end, remember, because of the fact that this is not from 0 to 2 pi, I'm going to add 2 pi in to each of these values. So to this one, this one, and this one. Okay. And that's what we'll do. We'll leave that as is. Okay. Awesome. Let's see how many other viewers are there from Sweden. How many viewers are all the way from around the world? We got 2 viewers there. I lost a couple. Again, hopefully this is getting helpful. This is helpful for y'all as we progress. Hopefully this is getting there. Please again text me if you have any questions there. I'm going to do probably I think 2 more problems here, and if I don't have any more questions, then we'll be good to go. We'll kind of go from there. Actually, before I do that, before I get to those last questions, we should know how to factor an identity. That's a big one. So like 3a. So this will be my first one. In fact, I'll do this one. Okay. Good. We got this one. Okay. It says also double angle formulas. You're good there. Showing steps. Yeah. Make sure you show steps on your identities. Just kind of a couple notes for me on that. And then I'm going to do one more. And then if you're good to go, then we're good to go. You don't need it there. But if you need another one, please feel free to do that going forward. I'm going to make one other one up. This would be a good one. I'm going to do sine squared x minus sine of x. Actually, that's a pretty good one right there. Okay, so let's do the top one first. One thing we want to remember with the top one is we want to factor, right? So one thing we want to try to do is try to factor this. So really, if we can envision this is the first term, and then this is the second, and this one is the third, and kind of go forward with that. That's kind of what we're looking at and trying to factor these two, or these 3 terms. And this should be a 2, by the way. That's what threw me off. I was like, what? Okay, so that should be a 2 right there in front. So my question is what 2 numbers when multiplied get me? Because it's a trinomial. What 2 numbers when multiplied get me 1, but when added get me -2? We know it's going to be like -1 and -1. But it's not just going to be sine, though that's part of it. The reason we have 2 values, the first 2 values, have to multiply to get to that first one, sine to the 4th. So we have to do something with that. So it's not just sine. It'll actually be sine squared. Sine squared. So right now we've got sine squared minus 1. And so then I think to myself, okay, is there anything I can do? What is sine squared minus 1? So I think about that, and I think, okay, I know that cosine squared, this should be squared, I'm sorry, plus sine squared is equal to 1. So if I subtract 1 to both sides, and then subtract cosine squared, I know that sine squared minus 1 is actually negative cosine squared. So what I could do is actually change this to say negative cosine squared times negative cosine squared would actually be cosine to the 4th. Okay, and so that'd be like cosine to the 4th of x. And that's just one way we can simplify it by using factoring and using our identities there. Awesome. I do see 14. I hear you're 14. Let's do it. In fact, we'll do that one in just a second. In fact, let's do that one here just shortly. Here's another one I dreamt up. Good one for the test. Again, this one is one where we're trying to solve here. One thing that we could do on this one is we could take out like a sine, right? We could take out like a sine of x. So once I take out a sine of x on this, what I'm left with is sine of x minus 1. Okay, that's what I'm left with, sine of x minus 1. So what I could do in this situation is, since both are being multiplied, I can set both of these equal to 0 and solve. So like for instance, sine of x equals 0 and sine of x equals 1. Okay, and the reason why I can do that is because they're being multiplied. So if this is 0, then the whole thing will be 0, because anything times 0 is 0, right? And so we actually set both equal to that value and go from there. So my next question is what can I do? We'll assume that it's from 0 to 2 pi on that interval, right? We'll kind of assume that there, okay? What can I do? What 2 values when I look at the y, it has a value of 0. And as I do that, I know that it's going to be at 0, okay? And it's up to 2 pi, but not equal. So we'll say 0. And the next one we know is pi, right? because again, we're talking about where's the y 0, it's at 0 and pi. Then I say, where's sine of x positive 1? And what I could do is look and think, oh yeah, I know it's at, the y is at positive 1 when it's at pi over 2. So what we have now is we have those three specific values, and we'll leave those as is, and those are the three values between 0 and 2 pi. Okay? Awesome. Let's look at the next one, number 14. 14, I like 14. Okay, so Jacob, one thing on this one that we want to try to focus in on is we want to try to get the signs by itself, right? So like, for instance, on this, we can add sine of x, right? And when I do that, I get how many sine of x's on the left side? Well, I get 2, right? So we get 2 sine of x equals square root of 3. So now this is where I divide by 2, cancel, cancel, where sine of x is equal to square root of 3 over 2. So kind of the same type of thing here. Again, put those signs on one side, divide by 2. Then where's sine going to be square root of 3 over 2? And I think it's going to be at 2 spots here. And again, I shouldn't have plus or minus because I'm not square rooting a squared. It's a little bit different on that. But where's sine square root of 3 over 2? It should be at pi over 3, I believe. And at 2 pi over 3. Now, since this situation, it did not have the interval from 0 to 2 pi, I just add 2 pi into it. And that will rotate it around n times, and it will go to infinity and beyond. Okay. All right, like I said earlier, please feel free, if you have any other questions, please text me. I'm going to just kind of hang out on here for just a little bit longer and kind of go off that. So go ahead there, and again, I'll wait for another couple minutes, and we'll go from there. So if you got any other questions, throw them out. All right. Yeah, I see number 8 there. Let's look at number 8, and I might come back to actually number 11. I want to make sure on number 11 there that I hit on that one. Remember Jacob on this one, on number 8. Let's see here. I'm actually going to get out of this. I come to number 8 there. I was actually looking at one. I want to make sure I did this one right. In class, I think I did do this one right. I just want to make 100% sure. So I'm going to come back to 8. I'm looking at number 11 in case you're following me through here. And by the way, the answer sheet is posted online, so you could kind of go on there and look at that one on that specific website there. Perfect. Okay. Gotcha. Make sure of that. I'm just looking at one real quick, y'all. I'm sorry. I did it a little bit different than what the review said. And I want to make sure I just did this right. So apologize. Give me just a second here. Just want to make sure I'm all good. Yeah, okay, that worked out actually. I think there was one that I had done on the homework that was just a little bit off on what I was saying to do there. And again, what I was trying to do is I was just making sure. I don't think I did it on any of the podcasts at all. But I'll look and see if y'all could remind me before the test to make sure there's not one. Just remind me of this conversation. We'll hit on this one and go from there. Okay. All right. So like we were saying earlier, let's do number 8. Number 8 is a good one, and is one that probably should finish off with. That'd be probably a good one there. So let's do this. 1 plus cotangent of x there, all over 1 minus cotangent of x. We know that the left side's the most difficult. That's a given. One thing we remember too is that the square root can be it can go to both. So we're going to multiply top and bottom, or let's just do this. Let's rewrite it as square root of 1 plus cotangent of x, all over the square root of 1 minus cotangent of x. Okay. So I'm going to multiply top and bottom by the conjugate of the bottom, so to speak, should be square root of 1 plus cotangent of x. And we'll do that the top and the bottom side, okay? All right, so what we have now is, remember, if we have two square roots that when multiplied are like the same thing, like square root of 1 plus cotangent of x times square root of 1 plus cotangent of x, it'd be the same as saying what is the square root of 3 times the square root of 3. We know that that answer would be the value of 3. So on the top, we should hit 1 plus cotangent, and that's it. Now on the bottom is a little different. Because we have two square roots inside, or we have two square roots with things inside, we can distribute the 1 plus cotangent. We're going to multiply that by 1 minus cotangent. And you should pretty much know conjugates enough to where you can distribute if you need to, but you could pretty much recognize that this is going to end up being the square root of 1 minus cosine, or cotangent rather, squared. Okay, 1 minus cotangent squared. Or this is cosine, I'm sorry. All these are cosines, my fault. But the whole process is the same. So this should be 1 minus cosine squared, my fault. It's all cosine. I don't know why I did that. My fault there. So all of this right now on the bottom is 1 minus cosine squared. We know that 1 minus cosine squared is sine squared, right, with an identity. So we know that this is equal to 1, or just sine squared. So we should have 1 plus cotangent, or cosine, I'm sorry, all over square root of sine squared. And the square root of sine squared is like, if I do that, they cancel, right? Leaving me with just the absolute value of sine. Apologize for my baby in there. And at the top, we're left with 1 plus cosine. And so that would be it. Remember, too, and this is really the tough part, the absolute value part. It's tough to remember, but remember that we see the other side, right? We see the other side, and because of that, we can then simplify and kind of go off that, go from there. All right. Oh, awesome. As I did that too, I actually noticed that the top part, man, I really wrote that down wrong. I apologize. This should really be minus. And so again, like I said, should be, I think I flip-flopped those. Did I flip-flop those? I think I did. However, it will be the same thing. I flip-flopped the plus and the minus on there, and I apologize for that. But as you go back through, you can identify that instead of multiplying, if this is plus, I'd multiply by 1 minus cosine, top and bottom. But the process would still follow kind of the same pattern there. Just your result would be 1 minus cosine over absolute value of sine rather than 1 plus. Apologize for messing that one up there. I apologize that. So awesome. Fantastic. Okay, well, I think that's it for tonight. Unless I'll hang on there for another about 20 seconds here. And if you have any other last minute questions, you could kind of throw them out there. And we will rock and roll. Again, remind me of that one before class. I don't know if there is one on the test like that. And I think I had just tweaked something. I need to tweak something real quick before we take the test. Make sure I go through everything, and we'll rock and roll. All righty. Awesome, awesome. Well, that looks like it's it. Have a great night, y'all, and we will talk to y'all later, and we'll see you all tomorrow. Bye now.